lesson talking about the area and perimeter of trapeziums as well as parallelograms. Okay, so just do a very quick recap. I want to recap on perimeter because I think perimeter is straightforward. You just have to add up the sides of everything around that figure itself. Okay, so area of parallelogram. What is the formula that we learned? What was the formula? Base times height. Okay. What about trapezium? That will be half times sum of parallel sides times the corresponding height. Okay? And the unique thing about heights is that they must always be perpendicular with reference to the height or to the base, okay, or the sides that you're looking at. So therefore, recognizing heights are very important. Hence, we are going to be looking at this activity. Okay, this is the one that is in your worksheet under parallelograms first. Okay, so I want you to label out the height, okay, for the respective bases over here, and also identify the bases for the respective heights over here. You may use your ruler method, okay, to guide yourself, identify. So maybe to start off together, I did bring my large ruler here today. Okay, so you can align your ruler such that it is perpendicular to the base that has been indicated here. Okay, for parallelograms, your perpendicular height, so long as it reaches, okay, the opposite side of your parallelogram, it will be sufficient already. So you can have your height to be in this manner, okay, that is perpendicular. Otherwise, any other lines, okay, even on this side here, okay, they will be equal in length. You see? Okay, so use your ruler to guide yourself in terms of identifying the base and height. Will you please do this now? Okay, I'll give you about 2 minutes to do so. Okay? Yes. It doesn't matter whether you draw dotted line or solid line because you won't be tested on drawing the line. Okay, I just want you to be able to recognize. you put in a nitrogen variable, please. Thank you. Okay, so let's check our work. Okay, so part B, Ethan has given us that this will be the height, so let's label it. I realize I forgot to label earlier on also. What's this? What happened? Just went. Okay. Anyway, so yes, this is the height. Okay, we label the height for H. Okay, then for Evan, he noticed that the height will have to be on the outside because if I have it inside, he realizes that it doesn't quite touch on the opposite side. So drawing on the outside is actually more convenient, and taking note that the base is actually referring to this one over here. Okay. Then for part D, he notices that the height will have to be here, but let's really be precise, it must be 90 degrees. Okay. Then in part E, Emmanuel recognizes that the base is actually here. Okay, so just to be clear, I'll draw in this. And then for Brandon, he also recognizes that the base will have to be this side here. And for Zayden, this is the base that he recognizes. Okay, and for Elise, just now I saw that she actually drew it in the entire length here. Okay, which I think some of us may have the tendency to do that as the base. Okay, we need to realize that base must actually be one side of the parallelogram. Okay, therefore you cannot have it fully extended out. Okay, otherwise it doesn't belong to the parallelogram anymore. Okay, now before we move on, just one question regarding part E to H. Okay, for these bases that your friends have actually listed out, right? Is it right for me to say that this is also the base? This is also the base. This is also the base, and this is also the base. So the ones that are indicated in green, okay, are they also considered the bases to the respective perpendicular heights? Okay, I have a show of hands. How many of you say yes? That the ones that are drawn out in green, they are the respective corresponding bases also. Who says no? Okay, now, then how many of you not sure? Okay, nothing wrong with being not sure. Okay, so maybe I'll say no. You said that no. Can you explain to us why you say no? Because the 90 degrees is here, not here. Okay, right? But the thing is that this is a parallelogram, isn't it? Okay, what's the special feature about parallelogram? The sides are parallel and they are equal in length. Agree? So actually taking this as the base is the same as taking this as the base, right? Because they are equal in length in the first place. Agree? Okay? So therefore, taking the green sides here, they are actually also considered the same base for their respective heights. Okay? Understand? Questions? Alright? So let's do the same activity for the one on trapezium. Okay? Trapezium, we're looking at bases, we're looking at heights for the parallel sides. They are indicated. Okay, so this is the question here. Can I just give you a minute to do this? On the board, please just indicate the refer to the answers below, please. The side that is
that has a 90 degrees on it.
Okay, so the one on top here, is it? Okay, so the one here, right? Okay, so yes, you can also indicate that this is the height because they are perpendicular sides in the first place. Right, but there's nothing wrong with whatever Kyra has indicated for us. Okay, it's correct as well. Okay. Alright, so we have learned how to identify the heights and the sides already. Okay, let's practice some questions. Okay, let's take a look at practice now 5B. This is in your textbook, page 154. Okay. The diagram shows a parallelogram ABCD, where AB is 30 meters, BC is 7, DE is 24. We want to find out what is the parameter and subsequently the area as well. Okay, I don't think it is difficult for us to determine the parallelogram. Sorry, the parallelogram, the parameter, what am I talking about? Parameter. Okay, so let's call a person. Okay, we just stand up. Nice. Suddenly, like, but I look at me like you don't know his own name, okay? See the yes. 7 bracket 2, okay. Plus 30 bracket 2, okay. So 2 times of 7 and 2 times of 30, and that should give us 74 meters, right? Okay, now what about the area? Okay, so let's call another Joshua. Z is the last one. Yes, Z, can you tell me how do we find the area? Sorry? 7 times 24. Okay, so 7 times 24, yes, that's correct. So it's either you write 7 bracket 24 or 7 times 24. Those are fine. And we will get 168 meters. Okay. Questions? Okay. So let's move on. Simple, right? Okay. Let's look at question 2. We want to find the parameter and the area in this case. So, but in this question, one important thing to note is that it is a rhombus. Okay. So each side of the rhombus is 8 cm. Taking note that rhombus is such that all the sides are actually equal in length. So in order to determine the parameter, what do you think it will be? JC. Easy, okay, last one. Okay, tell me what is the parameter? 8 times 4, right? Okay, yes. That's 32 cm. Okay, and what about the area? What do you think the area would be? See, KD. I think Ethan looks a little bit. What do you think is the area?
7.4 times
7.4 times 8, right? Okay, because it's not just about taking the two numbers and multiplying each other, but because this height itself is perpendicular to this side, and because this is a rhombus, okay, therefore we take 7.4 times 8 for the base and the height, and hence we will get 59.4 cm squared. Let's look at practice now 6. Okay, practice now 6, again we are given a rhombus. So keep in mind that rhombuses are actually a special kind of parallelogram. So therefore, it really doesn't matter whether it's a parallelogram or rhombus. Okay, so the same formula would actually apply, right? So in this case, the question says that the area of triangle PRS is given to be 48 meters squared. So PRS refers to this triangle here. Okay, and this area is given to be 48 meters squared. Such that we want to find out what is the length of RT. Okay. So how do you think we could go about finding out the length of RT? Okay, let's choose someone. Xavier. Okay, actually look a little bit simple. Yeah. 48 meters squared times what? 2. Why do you times 2? Oh, okay, so to find the entire area of the rhombus. Okay, so presentation wise, let's just be clear. Area of rhombus equals to 48 meters squared times 2, and that will give us 96, right? Okay, then what do you do next? To find the length of one side of the rhombus. You want 96 divided by 10, right? What are you trying to find? Or could you form for me an equation telling me what times what gives me 96 for area of rhombus? Based on this diagram itself, the entire rhombus, how would you have found the area if I have the necessary information? What times what will give us 96? What is the base? What is the height? Do you know the height? 9.6. Can you tell me which side? Name it, okay? This is side SP, this is side PQ, this is side RQ, this is side ISR. It's a naming of the system, of the parallelogram, or this rhombus here. Okay, can you tell me which side is it? Which line gives us the height and which line gives us the base? Or you want to come out and point out? Easier. Which side is base, which side is height? Francis, you want to help him out? Wait, let's flat-axial triangle. Okay, actually maybe I tell you this is a parallelogram, this is a rhombus, right? Okay, I can have this as my base. And where is the height? What is the height called? TR, which is what I want to find, right? So this is the height. Okay, for which base times height, based on our formula, will give us the area of the rhombus. So, what is the length of PQ? Do you know? 10, right? Okay, because this is a rhombus, so the base is 10 meters. Okay, so 10 times RT, because we don't know what is height. That's precisely what the question wants us. Right, so 10 times RT is equal to 96. So just now, when you take 96 divided by 10, what are you trying to find? You are trying to find RT. Okay, thank you, have a seat. Okay, so therefore your RT is actually 9.6 meters. Alright, so this is the method that Asia has decided to propose. Just wondering if anybody else has a different method. Anybody else have a different method? No? Okay, I know that we have been looking at area of parallelogram, area of the entire rhombus, and so on. Okay, but actually since you're given the area of this triangle, just wondering whether you are able to observe that this is a triangle, right? Okay, I know that this, if I take it as the base, okay, where would the height actually be? Okay, the height will actually be this over here. It will be the same line. Okay, same length as RT. Agree? Okay, so therefore, if I reconsider, my base is actually 10 because this is after a rhombus. Okay, I can consider half times base times height, which is RT, will be equals to 48. What I'm using here is area of triangle. Okay, so area of triangle. Triangle PRS equals to alright, area of triangle formula we know half times base times height. Okay, so therefore RT equals to 48 divided by half divided by 10, and we also get 9.6 meters. Okay? Questions? Alright, so we are not limited to just solve it in this manner, but of course if you think in this manner, perfectly alright, nothing wrong. Okay, just wanted to show you a different way of solving it as well. Okay. Shall I move on? Okay. Now let's take a look at practice now 7. Okay. We erase all this. Okay. In practice now 7, we are given a diagram that shows a parallelogram. And then ABCD, the parallelogram is ABCD, and then there's a smaller parallelogram, PQRS. Okay, P and S lie on AD, and Q and R lie on BC. We are given that AD is to PS is equals to 5:1. So how do we understand this ratio? It means that AD can be 5 units long. Okay, while PS is actually 1 unit long. Okay, so this is what we understand about AD is to PS. 5:1. It doesn't mean that it is 5 cm and 1 cm. It can always be 25 cm and 5 cm, so long as the ratio simplifies to 5:1. Okay, the question wants us to find the ratio of the area of the parallelogram ABCD, that means the entire big parallelogram, to that of the area of the parallelogram PQRS. So we want to find the ratio of the bigger parallelogram to the smaller parallelogram. Okay? And what is the problem in this question? Is that they didn't give us any length, okay, for the parallelograms that is given. They never tell 7 cm and so on. Okay, they only tell you this ratio. So how do we go about determining the area in the first place when I want to try to use my formula? I want base and height, but I have no height at all also. Okay, so how? Right? So this is to challenge our perspective. Let me just adjust these labels over here. So we know this is 1 unit. Okay, and the entire length here is 5 units. Okay, since we know that the base and height must be perpendicular to each other, and because I only have such information, I will use this information, these sides over here, as my bases. Okay, then I will try to identify the heights. Okay, so the height itself for the longer one, we know that it must be perpendicular, so let me just use my ruler to be precise. Okay, so I recognize that this shall be my height. Okay, that's corresponding to AD. Right? But because PS is also on AD, this height, do you agree, is actually the same height. Okay, same height for both parallelograms. Because I could adjust this to perhaps, let me try. Sorry, I'm facing short people problems. Okay, so like that. Okay, so if this were to be my height, okay, looking at the smaller parallelogram, this is my base. What I did was I extend it out. Okay, such that my height is actually for this base. Likewise, my this height is also going to be perpendicular to the base AD as well. You all see it? So both parallelograms have the same height. Questions? You see? Okay. So therefore, okay, the area of the parallelogram. Okay, let's just put ABCD. Has the formula half times 5 units. Okay, let's just take it as 5. Okay, times the height. And then the area of PQRS, okay, going by the formula, sorry, not half, 5 times the h. Okay, the area of PQRS base times height, it will be 1 unit times the height. Okay, and since we're looking for ratio, we know that an equivalent form of ratio is its fraction. So if I were to take area of ABCD divide by area of PQRS, it is actually equals to 5 times h over 1 times h. Okay, why is it that I choose to represent it in a fraction form first? It is because in a fraction form, I know that I can conveniently divide away the h such that my ratio, my fraction, simplifies to 5 over 1 or 5 whole, which explains why the eventual ratio will be 5:1. A visualization challenge, okay, for this practice now 7, right? Let's move on, shall we? Okay, let's look at practice now 8. Are you familiar with this flag? Yes. Wow, I've never seen this flag before. How do you know of this flag? Is it where? North America? Central America? Wow, how do you know all that? You surprised me. what's interesting about this country?
In the Caribbean. These are octopus.
How do you know that? You all read up, is it?
No.
Then? Huh? You just know.
No, I just know.
Okay. I mean, you all don't learn this in geography, right? Okay. So, never mind, that's not our person here. Okay, so we're looking at this flag that belongs to the Republic of Trinidad. Okay, and Tobago is made up of two triangles and three parallelograms. I hope you can see the triangles and the parallelograms. Sorry, let me just adjust my slide. I think there's something hidden here. I think I intended to cover that up. Okay, so we have two triangles and three parallelograms. I hope you are able to see. The triangle is the red one. Okay, and then the parallelogram is actually the white, the black, and the other white one. Okay, so they say that the width of each white portion is 1/30 of the length of the flag. Okay, so this information given in the question, let's break that down to understand what it means. Okay, the width of the white portion, which is here, is 1/30 of the entire length of the flag. What this means is that if this is 1 unit, it takes up 1 unit out of 30 units, okay, for the entire length of the flag. Okay, so we can see it as that proportionality, that ratio between the length of the white portion to the length of the flag. Then, okay, the width of the black portion is 2/15 of the length of the flag. In other words, okay, the black portion which is here, maybe I should use green pen. Okay, so if this were to be 2 units, okay, the entire length of the flag is 15. But we notice that down here 30 units, the proportion is 1:30, while the other one is 2/15. It can be very confusing. So we change up the 2:15 ratio into a base of 30, and the equivalent fraction is 4/30. In other words, down here 4 units, down here 30 units. So I need not even have this. Okay, so this is the proportion that we have based on the question, based on the information given in the question. Okay, any questions out of here? Everybody can understand? Okay, how we use the information up. Then the question asks, calculate the area of the red portion to the black portion to the white portion. Alright? So, we recognize that the way I have labeled all my bases is at the bottom. Okay, I need to find out the heights in order to know the area of the triangle, which is half times base times height. Okay, and parallelogram, I also need base and height. I hope you are all able to recognize that since my bases are all along that same line, my height is actually all going to be the same regardless of whether is it a triangle or the white parallelogram or the black parallelogram. Okay, so my height, in fact, because this is a rectangle, my height will just simply be this one here. Very convenient. Okay, because rectangle down here 90 degrees. Okay, so the triangle, the black parallelogram, the white parallelograms, they all share the same height. Okay. So what does this mean? Okay, the area of the red portion, it is actually the two triangles. So since there are two triangles, we take 2 times half times base times height. Okay, height we know that it is h. Right? Now the base itself, okay, for the triangle, I'm going to take this as the base. And since the entire length is 30 units, okay, let me just adjust this. This entire length is 30 units. How long do you think the base will actually be in terms of units wise? 30 minus away, 1 minus 4 And not forgetting there's also 1 unit over here. Okay, so I will take 30 minus away 6 and that will give us 24. Okay, so half times 24 times h, that will give us the area of 1 triangle followed by times 2 for the area of the 2 triangles. Okay, then we look at the area of the black portion, which is a parallelogram, such that the base is 4 and the height is h. So 4 times h. And then the white portion, since there are 2 parallelograms here, times the base 1 unit times the height h. Okay, then I can proceed to simplify it. Over here, I can calculate first. I will get 24h. This is 4h, and this is 2h. For which, okay, whenever we simplify our ratios, we can divide across by the same number or the same quantity. Because h is actually a number, okay, itself, but we do not know the number, it's okay. We can just simplify by dividing across by h, such that we get 24 is 4 is 2. And then we simplify this by dividing by 2 across, we get 12 is 2 is 1. Especially when we go up to maybe Set 3 or even Set 4, okay, this skill will be quite commonly used in terms of counting units. Okay, so there are times if I will not given any length itself, okay, but we're given you information about the units. So we take that proportion, okay, to count. Right? Now let's move on to trapeziums. Okay. So let's show this already. Right? Let's take a look at this one. Okay, trapezium we only have 2 questions actually. So in this case, we want to find the parameter. Okay, let's call out another name. Decide what is the parameter. Colin. Gigi will answer, is it? Okay. Yes, Gigi. Can you tell me what is the parameter? Plus what? Plus 5 plus 6 weeks. Okay, so that will be our parameter, and that comes out to be 29.7. Okay, and then what about the area? Okay, how do we find out the area of this trapezium? Let's see. Oh, Jushin. I don't want Jushin again. Okay, but I think the last one that's there before Jushin is either Colin, otherwise Kyra. Your scissors paper stone. So you want to give Colin the chance. Okay. Colin give you the side, or what's that called? The side eye, yes. Yes. Colin, may you tell us what is the area? 13.2 times 4, you sure? This is a trapezium, you know. We have the formula here. Half times 29.7. Why 29.7 then? 11.2. Where are your numbers coming from? Sum of parallel sides. That's what I mean over here. What are the Okay, so we key that into our calculator directly and we'll get 26.4 meters squared. Okay. Right? Yes, Joel? Okay, make it quick. Okay. Right, one last question for the day. If we want to find out, in this case, we're given, before that we're given PQ is 14, RS is 10, the area is actually 72 meters square, the parameter is 37.2 meters. Okay, so we're given the area and the parameter instead. Okay, and then we want to find out what is the length of PS as well as the length of QR. PS is actually here. Okay, so that is the first thing that we want to find. How do we find the length of PS? Let's coordinate. Lucas here. Lucas himself. Okay, Joel predicted already. He counted that he will be caught. He will be affected. Yes, Lucas. Can you tell us what is the length of PS? How do you find it? Okay, if I give you a hint, we make use of the area of the trapezium. The area is 72. How do we find the area of the trapezium? Using the formula. Half times what? Can you fill in the blanks? Using my information. There will be things that we don't know. Half times 24. Okay, you get 24 because, how do you get that? Sum of sides. So 10 plus 14, not any sides, must be parallel sides. Then times the height, which is called PS in this case. Right? Because W times degrees. Okay? So now that we have formed this equation already, okay, you may choose to simplify it. You can do half times 24 times PS, which gives us 12 times PS. Okay, so that means that PS, so Lucas, can you complete this? PS is equals to, I know that 72 divided by 12, right? Okay, so 72 divided by 12 and we will get 6 meters. Okay, so notice how I always form an equation, okay, with the information. Okay, I know the area, the value of the area, and I know that I can form an expression, okay, using the formula itself. Okay. Then lastly, part 2. Okay, we want to find QR. So we already know that PS is 6 meters. So finding QR, what would that be? Okay, 5 chance to speak. Yes. Okay, you can give me what is the length of QR? The 7.2 minus 10, 14, and 6. Okay, so we just take the parameter and subtract everything else, and that will give us 7.2. Okay, and that's all when it comes to parallelogram and trapezium. Okay, and therefore at the end of the chapter, we always got homework. Okay, exercise 4B, question 4, 5, 7, 9, 13. This homework shall be due on next week. time, I'm going to go into chapter 13. Okay? Then after that, for your SLS, it will also be chapter 13 related. Okay? Tomorrow's lesson on chapter 13 will be on volume and surface area. So